Yo, good neighbor. We just finished school this morning, Forrest and I, and our last subject was science, which he's studying astronomy right now. And we are just talking about the cycles, the phases of the moon, um, and learning about crescent moons and gibbous moons and first quarter, first quarter, third quarter, full moon, new moon, all of that good stuff. And something I had just learned recently, probably within the last 6 months or so, is that the moon and the earth, as the moon orbits around the earth actually wiggles a little in its orbit going around the sun. There again, it takes about 28 days for the moon to go all the way around the earth, which is like 13 times as we go around the sun in a year. Anyway, I just looked it up so I know that what the term is. I couldn't remember what it was, but it's called a barycenter, B-A-R-Y-C-E-N-T-E-R. And the actual point, the Earth is here, and then the smaller moon is out here, and the moon is orbiting the Earth. But the Earth they orbit around, the Earth actually orbits around the moon to some extent. They orbit around the barycenter, which is the center of the combined mass of Earth and Moon, which is actually about 1,000 miles deep under the crust of the Earth, or 500 miles down. So the moon and the Earth is like a dance. You see a man and a woman dancing, and the man is heavier than the woman, and they're dancing, and you see him swing her around. Well, he's not actually staying put. He's actually moving a little bit as she goes around him. Well, that's sort of like sort of a crude example of the dance that we do with the moon. And it's interesting. I didn't realize that we aren't stable. And that partially explains why the tides act the way. See, some of this stuff is never really perfectly explained through science. Why is there a high tide? We know why there's a high tide on the side where the moon is today. But why is there a high tide on the opposite side of the Earth as well? It may have something to do with the way this whole barycenter thing is working, in that the moon is not just pulling the water, but pulling the Earth as it goes around every 28 days. So that can explain why there's high tides on both sides at the same time. It's just that the ocean is basically sloshing around as we do this dance every 28 days. There's 2 high tides every 24 hours, roughly speaking, as we spin around under the moon as well. It's very complicated, and there's very little common denominator in any of these measurements or numbers, days, time, whatever. It's not a perfect 28-day. In fact, our 24-hour day isn't really a perfect 24-hour day, probably. We have things built in there. Leap year, for instance, going around the sun every 365 and a quarter days. It's interesting stuff. I've always been interested in astronomy. We talked some of the moonshots and so on and so forth. And we have a friend, Apollo 13, the one that almost didn't make it back. We have a friend we're going to be visiting next month. Her dad was on the team that helped build the contraption to purify the air on Apollo 13, so that they could get home. They have enough breathable oxygen to get home on. So that's evidence that we really did go to the moon. There's controversies concerning that, and there's some interesting, supposedly, photographs out there that would say, yeah, that doesn't make sense if they were on the moon. But I guess I can't. I always wanted to be an astronaut. When I was Forrest age, didn't make it. Have a good day.